In this podcast, we are going to be talking about chemistry. And I know some of you are probably thinking, why are we doing chemistry? We are in biology, Ms. Dellosso. But we actually have to have a basic understanding of chemistry in order to better understand biology, especially when it comes to describing the basic substances of life. So let's first define what chemistry is. Chemistry is the study of the composition and properties of matter and the energy transformations that accompany changes in the basic structure of matter. So we are going to be focusing on matter and also energy. In today's podcast, we're going to be talking more about matter and what it's made up of, and some of the properties of it as well. In the next podcast, we'll talk about the energy in chemistry. All right, so let's recap on our definition of matter. Matter is anything that occupies space and has mass. There are three states of matter: solid, liquid, and gas. And these states are the results of varying amounts of energy possessed by that matter. So for example, if thermal energy is added to the ice or the solid water, the water will then enter the liquid stage. And again, if thermal energy is added to the liquid stage or phase, it will then enter into the gaseous stage. And matter is composed of elements. Elements can be defined as pure substances that cannot be broken down into simpler substances by ordinary chemical reactions. So according to atomic theory, if a piece of an element such as the pure gold that we have here is cut in half and then in half again and again and again, in time there would be a piece that could not be cut again and still be gold, and that piece would be the atom, which would then be the smallest unit of an element. So here's our periodic table of all of the elements. So on here, this is where the elements are arranged according to their structure of their atoms. And this table displays the element symbols. It's usually the first letter or letters of the chemical names in Latin or English. We can also find the elements of life, or the elements that most organisms are made up of. For example, carbon is one of those elements. We'll jump over here. Hydrogen is another element that makes up living things. We also have oxygen. Right next to it, nitrogen, and also calcium will be very important as well. So here is our periodic table of the elements. So I just mentioned to you before atoms. Atoms are the smallest unit of the element, and atoms are actually made up of smaller parts called subatomic particles. So an atom has a nucleus, which is made up of protons that have a positive charge. They're also made up of neutrons, or neutrons are also found in the nucleus, which have a neutral charge. And outside of the nucleus, we're going to find electrons, which have a negative charge. So let's see what this looks like on a carbon atom. So here is our carbon atom. Inside, we're going to find the nucleus, which contains the protons and the neutrons. And outside of the nucleus, here are our electrons. And if you notice, most of the atom is actually made up of a lot of empty space. The electrons are also constantly in motion, as you can see here. All right, let's talk about an element's atomic number. This is equivalent to the number of protons found inside the nucleus of the atom. So again, the atomic number is the equivalent to the amount of protons it has. Each element is assigned an atomic number on the periodic table. Also, however many protons the element has, it'll also have the same amount of electrons. So let's see what that looks like on the periodic table. So here is a sample of an element, radium, from the table. Over here, we're going to focus on the atomic number listed right here. So the atomic number for radium is 88, which means that it has 88 protons. Now let's take a look at the mass number of an element. So the mass number is equivalent to the amount of protons and neutrons, and if we look over here and follow our arrow, the mass number for radium is 226. And again, that includes the protons and the neutrons. So knowing the atomic number and the mass number, can you figure out then how many neutrons radium has? Think about that for a moment, and then we'll talk about that tomorrow. All right, let's jump to isotopes. Isotopes are atoms having the same number of protons but different numbers of neutrons. And the isotopes of an element have the same chemical properties, and I'll tell you why in a second. So let's take a look at carbon. Carbon has 3 different isotopes. It has carbon 12, carbon 13, and carbon 14. And if you notice, all 3 of these isotopes, they have 6 protons, but they differ in the amount of neutrons. And how do they still have the same chemical property? Well, that's due to the fact that they still have the same number of electrons. And also, since the neutrons have no charge, the atom will have the same charge but different mass. So each isotope is identified by its mass number. Hence, we have carbon 12, carbon 13, and carbon 14, because the mass number is from the protons and neutrons combined. So carbon 12 has a mass of 12, 13 has 13, and 14, and so forth. So again, isotopes, their atoms have the same number of protons but different numbers of neutrons. Okay, now we're going to start talking about the different bonds. The first bond that we're going to talk about are ionic bonds. An ionic bond is resulting from the attraction between oppositely charged ions. And the example that we're going to look at today are sodium and chlorine. So what is an ion? An ion is an atom with an unequal number of protons and electrons. So how does that happen? Because we know from the atomic number that the number of protons means that that atom has the same amount of electrons. So most atoms are unstable and will normally bond with other atoms to become more stable. So an atom is most stable when its outermost electron shell is full. So what does that mean to be full? So the innermost shell can only contain 2 electrons. So let's take a look at sodium. So the innermost shell, the most amount of electrons that it contains is 2. The second shell can hold a total of 8 electrons, and the next shell has the potential to hold 18, but acts as if it's full when it is 8. So an atom becomes stable when those shells are filled according to the amount of number it can hold. So sodium, if you notice, the outermost electron, or the outermost shell rather, only has 1 electron here. Chlorine has a total of 17 electrons over here. So there's 2 in the first shell, there is then 8 in the second shell, and 7 in the third shell. So if it gets 1 more electron, it will have a full outermost shell. Sodium, going back over there, is the opposite. It has 11 electrons, again 2 in the first shell, 8 in the second, and 1 in the third. So it is going to actually give up its outermost electron, so it will have a full second shell. So sodium will give up this electron and transfer it to chlorine so that it will have a full shell here, making it more stable. When these 2 elements meet, then sodium gives its outermost electron to chlorine, and a new substance is formed, and that's sodium chloride, which is actually table salt. So this causes the atoms to have an unequal number of protons and electrons that are now called ions. So now these are ions. The chlorine becomes negatively charged because it has more electrons than protons. Since the sodium atom is missing an electron and has more protons than electrons, it becomes a positively charged ion. So since the positive and negative charges attract each other, the sodium ion and chlorine ion are attracted to each other. And here is a diagram representing the formation of ionic bonds. So just like the sodium and the chlorine from the previous slide. So there's our electron being donated, forming an ionic bond. The last thing we're going to talk about are covalent bonds. A covalent bond is a bond between two atoms resulting from the sharing of electrons. So hydrogen over here only has one electron and requires another to fill its shell, because remember, 2 in the first shell will make it stable or have the full shell. Oxygen has 8 electrons, 2 in the first and 6 in the second shell. So 2 more electrons would complete the second shell of the oxygen atom. One oxygen atom will therefore combine with 2 hydrogen atoms. The oxygen shares 1 electron from its second shell with each of the 2 hydrogen atoms, so that each hydrogen atom has a filled shell. So the 2 hydrogen atoms share their electrons with the oxygen, so that the oxygen has a filled outer shell. So covalent bonds are resulting from the sharing of electrons, not necessarily one donating one to the other. So let's see what that looks like. That's our water molecules. So let's see covalent bonds in action. So here we have our 2 hydrogen atoms sharing those electrons, forming water. So this concludes our first video on chemistry. Please make sure you go over the differences between the ionic and covalent bonds, as well as knowing the difference between atoms and elements, and also defining matter.